Be better.
I'm sorry, y'all. I'm not used to this, okay? I'm trying. I'm trying. You know, report me for saying shoot. I've said far worse in the classroom. All right.
Oh yeah, you could tell. You could tell Anthony.
Good lord. Please don't report me, y'all. It's okay. It was before I started recording, so it's fine. There's no evidence.
Did you see Tupac Minion?
What?
Did you see Tupac Minion?
Yes. Okay, Kayla. I just started recording it, and then if people get confused on the top part, I'll go ahead and help them with it.
Yeah.
Don't worry about it. Have a good day, Kayla. Okay, I don't know if she's still here. If she is, I can't tell. Anyway, let's continue. So, now, translating logarithmic function. So we know that this is a type of logarithmic function, right? Like this is what the general graph looks like. And now we have to translate it. So we remember like shifts and such. Hopefully, we remember what those are and translations. Hopefully, we do. Do it. Great. So, what kind of shift would this be?
Standard form.
What shift? Shift. Like remember translation? So like up, down, side to side.
Second gear.
No.
Reverse.
No. Remember, this is a vertical shift. I didn't leave enough space.
Oh yeah.
Vertical shift. Yes.
Sixth gear.
All right. And so this is going to be the same, and we'll talk about it in a minute, what it means by the same. All right. And then on this side, we have a, what kind of shift? If we have a vertical shift over there, what's this one? Good. It's going to be upwind. Very good, y'all. All right. But this one is going to be what?
It's gonna go to the right 6.
It's going to go to the right 6. Exactly. And so that's the opposite, right? The sign is the opposite of what we normally think.
Oh.
That's what I meant by same and opposite. Okay.
Yeah, I get it.
Good. So that'll be to the right 6. Make sense? Are we good? Are we happy? Do we understand? That'd be our answer. All right. So for this one, let's find the translations here. Nice and easy.
Up 9. I mean down 9.
Okay, good. So this is the vertical.
Right.
So it's down 9.
Right 2.
And it's going to be, because it's negative, right? But it's opposite. This is going to be to the right.
What does the logs mean?
We'll talk about that in a sec. But it's just a type of function.
It's a typo.
It's like an operate. It's like an operation.
No.
It's the opposite of exponents, basically. Okay, we'll talk about it though. All right, so y'all go ahead and do number 4 real quick, and then we'll talk about it.
Down 3.
Shh, quietly. Do it for yourself, and then we'll talk about it together.
Left 5.
All right, so go ahead and either type out your answers into the chat or verbally say it.
Up 3, left 5. Everybody type it.
Thank you, April. That was very
No, April, you're wrong, dude.
Shh.
It's not Spanish class. Kabiya. It's not Indian class. Kabiyabu.
Indian class? Oh, up 3, down 5 means nothing. Up 3, left 5. And why is it left instead of right?
Because it's a plus and it's inside parentheses.
Yes, it's a plus, and it is inside the parentheses.
Because if you put -5, then it'd be x equals -5. Right?
Yes, I think. What's wrong, Casey? No one cry. No crying.
She just watched Titanic again.
What? Okay, y'all know I can't deal with crying in class. Like, I don't even know how I would deal with it from, like, here.
Man up.
You can't see me, so.
I mean, that's true. But, like, if you, like, cry, like, if I knew you were crying, I'd feel bad.
Bro, April, can you just man up?
Okay, literally, what?
I'm a
They're like the
girl for
whitest
sure.
people known to mankind. Man up is the stupidest phrase. Anyway.
It's the best phrase.
Oh my
I
god.
live by that phrase.
Men get a cold. Men cry about a cold. Like women
No.
can only deal with that crap. So.
If you-
All right. So this has been an exciting conversation. What is the? So if we look at this graph, right, it looks different from this graph in that it's shifted, right? So let's go ahead and look at our transformations right here. What transformations do we have?
Right one.
Wait, Leslie. Is Leslie okay? Oh, we were talking about crying. Wait, I thought April was gonna cry. I'm so confused.
You know why she was crying?
No.
Because April is spring, and spring always rains, and she's April, so she's crying.
Ha ha ha.
Oh my god, y'all.
That was a good one.
Okay. What are the transformations here? Oh, got it.
Right one, up two.
All right, so this is gonna be up 2
Yes, ma'am.
and right
One.
exactly.
Yes, ma'am.
Okay, so we're pretty good about that. All right,
Lame dog.
now
Oh my god.
we're going to look at domain. All right, so what is the domain of this graph?
One.
What is the lowest number?
One.
1. Does it ever touch the 1?
Yeah, I've seen it.
No, that's an asymptote. Remember, an asymptote, it never touches.
I'm literally looking at it. It's touching it.
It does not touch it.
It's literally touching it.
Okay, so 1, it doesn't touch 1, and then it goes all the way to what?
Infinity.
Infinity. What kind of infinity? Positive or negative?
Positive. You know how I know? Because there's an arrow pointing to it, and arrow means infinity.
Sure. Yes, let's do that. Okay. So that's your domain. Much easier than the domains we were doing before.
Could you put your thing down?
What?
Paper?
You move the paper. I can't see it.
Yeah.
This way?
Yeah, I like it like that. Yes.
Okay. Sweet.
This is in penguin class. Yeah, penguin.
Sorry, you have to tell me. And then, yeah. Wait, 7? I'm confused. Okay. All right, so remember what domain is. It's just the x values, and the x values start at 1 and go all the way to infinity. Okay? All right, let's go ahead and do 6 and 7. So we're just going to do the same thing with domain. Now we just don't have a graph. So let's start with, oh no, penguin. I love penguins, y'all. They're so dumb and so cute. So let's look at number 6 and number 7. So what shifts do we see in each of those? All right, so we don't have any up and down. We just have horizontal. But what do we have? Good. Thank you, Nyla. So this one's right 5. All right, and what about the other one? Left 2. Very good, Jason. Good. All right, so we're all good on that, I think. If we're not, please speak now so I know, because I can't see your faces and I can't tell if you're confused. Cool. All right, so from here, now we just do domain. So like what we saw up here, right, where the domain means if it moved right 1, so then x equals 1, right? So that's how we approach the domain. Here, we moved right 5, right? So we're going to start with 5, right? 0 plus 5 is 5. And infinity. All right, and the difference here is it moved left 2. So if we move the asymptote left 2, then what is our x value for the asymptote? Any ideas? Not quite negative infinity, right? Because we're basically our graph, if we had our graph that looks like this, right? Our graph just moved left 2, right? So it's like this, and this is our asymptote. -2, very good. All right, because it moved left 2, so we went from 0. Left 2 is x equals -2. 0 minus 2. Think of it that way if you need to. Okay? And then, of course, positive infinity over here. How do we feel? You okay? Hopefully we are doing good.
Wait, so
Yes.
to get to the domain, we have to equal the things in parentheses to 0?
Yeah, that's one way of doing it. Yeah. You can either visualize it or, yeah, you could do it that way. That would make it easier, I guess. Okay. Cool. Cool. All right. So let's move on then. All right. There are 3 pages of these notes. These are long boys. All right. So let's start with the next one. All right. So for this one, right? Same kind of thing, but this time we're talking about exponential functions, right? These aren't logarithmic functions, they're exponential functions, right? And remember, we said exponential functions are the inverse or the opposite to logarithmic functions, okay? Okay. And we know we've already done a little bit with exponent rules and we just looked at logarithmics. So let's go ahead and do exponents with transformations. All right. So let's look here. So this +4 is what? What kind of transformation?
Exponential.
But what kind of transformation?
Up 4.
Remember, like,
Up 4.
yes, up 4. Very good. All right. So this is going to be up 4. And for now, like that would be a vertical shift, right? So, but when we're doing exponential, remember that's an inverse, right? So whenever we do exponential, we're switching what we do. So that becomes the new horizontal asymptote, okay? In a horizontal asymptote, right? Remember, asymptotes are lines that the graph approaches but never touches. And it's going to be y equals what? Y equals 4. Make sense? All right. So let's go through and try this out. It'll get easier in a bit. Alex, be nicer. Okay. Sorry, Early, that I didn't see that. All right, good. So y equals 4. All right, so let's try it with this one. Real easy. What does this make it? What's our transformation?
Up 7.
Up 7. Good. And so if it's up 7, all right. If it's up 7, then what's our horizontal asymptote? What is our asymptote, y'all? Very good. Y equals 7. Perfect. Make sense? Good. All right. So for the other one, again, we have this. This means what?
Down 2.
Down 2. Good. All right. So that gives us an asymptote of what?
Y equals -2.
Right. So this time it's y equals -2 because we're going down. Right? All right. So now that we know how to figure out some of these features, what we're going to do is we're going to graph, y'all's favorite thing in the world. I know. Exciting times to be alive. Yes, I will, Kayla. Once I'm done with the session, I'll scan them and post them. All right, so graphs. I know. This one isn't as bad as the other ones, though, I think, in my opinion. All right, so what kind of graph do we have here? Is it exponential or is it logarithmic? Let's start with that.
Logarithmic.
Very good. David, what is happening in your house?
I don't know. That's a good question. I just woke up.
Okay, good, Jasmine. So if it's logarithmic, right, then we're going to look at our transformations here, right? So what does the -3 mean? Any ideas? -3 means down
Down
3.
3.
April got there first, but yes. All right. And then this plus 2 means what? So because it's a logarithmic, we're not doing the same thing with asymptotes. It's okay. All right. Good. And this would be left 2. All right, good. So we've got that under control. So the left 2 means where is our asymptote? Remember, this is a log, so we're going to have vertical asymptotes. Left 2 means our asymptote is negative.
-2. -3.
-2.
Oh.
All right. So the thing is here, what maybe would be a good thing to write down somewhere is that an exponent, right, an exponential function, that's going to have a horizontal asymptote, right? And a log is going to have a vertical asymptote, okay? That's something you need to remember, okay? So here we have a vertical asymptote because it's a log, right? And that comes from this left 2, right? So our vertical asymptote, if we wrote it as an equation, would be x equals -2, okay? All right, good. So from here, after we do x equals -2, we've got that, right? Let's find our y-intercept. How do we find a y-intercept? Any ideas? Y-intercept means x is equal to 0. Right? Have you done logs before? Question. Right quick. No. Oh. That explains a lot. Okay. Cool. All right, so you haven't done logs before. That makes this a little bit hard to tell you how to do the y-intercept. Okay, that's fine. All right, we're going to do some logs. So if we do f of x equals 0, right, then we're going to plug in f of 0, right? Or here, I'm plugging it in 2 different colors. So we get f of something, right, equals log base 2. All right, so we're going to plug in 0, right, for x. Okay. So when we plug in 0 for x, right, we're left with this equals log base 2 of 2 minus 3, right? Okay. And so here is a new thing that y'all don't know yet, but you will know now, is that when you have the same things here and here, right, you can rewrite that as 1, okay? So that would mean that this is equal to 1 minus 3, which we know is equal to -2, okay? So what just happened there is we used a log rule, and we'll talk about those more. I think it's in 10B, so don't get too worried about it for now. But what you need to know is a log of anything which has a base, that means the number down here, that's equal to the same thing up here in the parentheses, is equal to 1. That's just a rule that y'all need to know. And we'll talk about it more, and there are other rules that we'll talk about. But for now, you just have to accept it. Okay? So that means our y-intercept is x is 0, right? So 0, and then y is -2, right? Which I'm going to rewrite down here in blue. Makes sense. A little bit. I know that's probably a little bit of a jump. But we'll be okay. All right, so when we plot that, 0, -2, x is 0, y is -2, there's our y-intercept. Okay, get it, April? All right. Cool. So we have our y-intercept, right? And we have our vertical asymptote. Now we just have to graph it. So in order to graph this, right, we're going to want to plug in another number, right? Let's see, what's a good number to plug in? For instance, we could find our x-intercepts, right? So to find our x-intercept, how do we do that? And then x-intercepts. So yeah, Kayla, you'll have a Unit 9 test when you get back. I can't do any common assessments over the computer. And if we don't ever come back, we'll figure it out then. Good. So for an x-intercept, y equals 0. I'm going to write it over here because I don't have any more space. Good. So y equals 0, right? Actually, here, I'm going to do this. So if y equals 0, that means this whole thing equals 0, right? So log 2 x plus 2 minus 3. Sorry, I don't put it up. All right. And so from here, we're going to just solve as best we can. So we're going to add 3, right, to both sides. Right? Cancel it out. All right, so we're left with log 2 Great. Okay. And from here, y'all really haven't done logs. I'm not sure how she wanted you to learn this, but you're going to try your best. Okay. So we need to know what a log means. An exponential form is 2 to the 3rd power equals x plus 2. And I know that's super weird how I did this step. Don't worry about it too much. We're going to learn a lot more about it in 10B. I'm not sure why it's in this order. I might be missing something, but for now, we're just going to do this, okay? Okay, so you just have to accept this, all right? From this jump to this jump we'll talk about, we'll do in 10B, okay? So don't worry too much about that for now, all right? All right. So from here, right, though, we can do 2 to the 3rd power is what? 2 to the 3rd power, anyone? Very good. All right, so we get 8 equals x plus 2, right? And then what's x equal to? 6. Kayla, basically, yeah, but it gets a little bit more complicated, so I don't want to say yes entirely. We'll talk about it a lot more. I'm going to make sure that y'all talk about it more. I just assumed y'all already knew this, which is what I think maybe she assumed as well, but you don't, so we're going to go over it in a lot more detail next week, okay? All right, so we get x equals 6, right? And so our x-intercept is going to be 6, 0, right? So we'd plot that here, right? And then from here, we're just going to sketch a graph, all right? So remember, it approaches but does not cross the asymptote, right? So it would go like this on this side. And then we go up, we connect these two, and then it just kind of goes up like that, like a nice gentle curve. Doesn't have to be perfect, just make sure it's curved and not, you know, pointy, right? We want it curved. All right. Good. So from here, using this graph, let's do our domain. So what's our domain? What is our lowest x value?
-2.
Very good. All right, so -2. And does it ever touch -2?
No.
No. So it's just a less than, right? Not a less than or equal to. And then we have x. And then what's our highest x value?
Positive infinity.
Positive infinity. Very good, because it goes on forever, right? In the positive direction. All right, then if you were to do our range, right? We're going to start with our lowest y value. Lowest y value, anyone? Why is everyone saying no?
Negative infinity.
Yes. And what is our highest y value? Why didn't you include a negative infinity, Kayla? Because it doesn't get to negative infinity, right? You would have to have points over here, right? Because this is the x values, right? And x negative infinity is way, way over here, right? And there are no points there, right? There's only points up until the green line, and there's no points everywhere else. So the lowest x value is right before -2, or right after -2. Okay? The domain just means what x values does the function cover. All right, and then our positive, of course, is positive infinity. I think you said that, so yeah. All right. I know that's a little messy, but I think y'all can do it. But we're going to try another one together. I'm not going to just leave y'all blinded. All right. Or like, I don't know, whatever. All right, so +1 means what? I'm sorry, April. This is like, it started easy like they always do, and it got hard real fast.
Can you please move your paper? I can't see.
Yeah,
Thank you.
sorry. Better?
Yes.
Okay, good. Thank you for telling me. All right, so that's up 1, right? And then this is very good, April.
4.
And also correct, Alex. All right. And then what kind of function is this? Is this a log or an exponent?
Log.
Log, right? Because it literally says log in it. So that's how we know it's a log, right? Okay, good. So a log means that we have a vertical asymptote, right? Okay. Okay, Alex, don't make me mute you again. Yes. I'm going to scan it and upload it just like I did with the last one, Fatima. Okay? Log cabin. What? Okay. How I get it. All right.
That's how
All right. So from here, right, we need to find our asymptote, right? So let's start with that. What is our asymptote? Any ideas? Remember, our vertical asymptote comes from this, right? 4. And what equals 4?
4.
What goes on this side?
2 squared equals 4.
X. Very good. So x equals 4, right? And then we're going to graph it, right? So x equals 4 here. Okay. So that's our asymptote right there at x equals 4. All right. And from here, what is... okay. All right, then scroll down. All right. Good. So from here, right, we know we can find our intercepts again, but we're not going to for this one because if we think about it, right, our graph, blah, blah, blah. Okay, let's find, so our graph is going to be over here, right? It's all, like the curve is going to be over here. Does that make sense? So do we have a y-intercept? No, we don't have a y-intercept, so there is none. None. All right, there's no y-intercept. All right. So if there's no y-intercept, we can find our x-intercepts, right? So we're going to do our x-intercepts again. All right. So x-intercept. Let's do it. So with an x-intercept, we know that y equals 0.
Y
Y.
equals 0.
Exactly. Good, good, good. All right. So here we're going to do 0 equals log 3 x minus 4 plus 1. Right? We're going to try to get the log by itself, just like before we would try to get the radical by itself, right? Same kind of thing. All right, so we're going to subtract 1 on both sides. So we get -1, the log 3 x minus 4. All right. This next step is going to be covered in 10b, so don't worry about not being able to do it right now. All right. It's going to be 3 to the -1 power. I'm just going to write the whole thing. And that's just the definition of a log, but we'll talk about it more. I'll make sure we talk about it, okay? Will the point always be to the right of the vertical? Yes, for now. If that ever changes, we'll talk about it, but I don't think y'all cover when they aren't, okay? Like it would be like a whole negative situation and everything else. We'll talk about it if they're gonna be on the left, but for now you can assume they'll be on the right, Kayla. Okay? All right, so from here, right, so we got to this point, right? What's 3 to the -1 power? We know our exponent rules, I hope. 3 to the -1 power is the same thing as 1 over 3, right? Equals x minus 4. How do we get the x by itself? Oh, there you go, David. It's okay. We'll brush up on our exponent rules this unit. Don't worry. All right, and then how do we get the x by itself? Anyone?
Add 4 on both sides.
Very good. So when we add 4, right, we have to do some basic fraction adding here, right? So to add 4, you'd have to cyclops multiply by 3, right? Invisible 1, multiply by 3, right? So then we're left with 12, right? So x would equal 13 over 3, right? All right, which is also known as 4 1/3, right? So either way, you can just plot it right over here, okay? So we know that our x-intercept after all of that is x equals 13 over 3 and y equals 0. Or you could write it as 4 1/3 and 0. Up to you. Okay? Good. All right, so then we plot that, right? We plotted it right here. It should probably be orange for consistency's sake. Right. All right, we don't have a y-intercept, so we're just going to graph it, right? So we know it's going to go like this, something like this, and something like that. Remember, it's never going to touch. Try not to have it touch. I messed up, but it's fine. What? Okay, cool. All right, and last but not least, let's do domain and range. So domain, what is the lowest x value here? Remember, x value is this way. 4, right? Because we don't have any points on our graph over here, just 4, right? And it never touches 4 because that's an asymptote. So it's just going to be that. And what's our highest x value? It is not 8 because there's an arrow.
Infinity.
Very good. Both of y'all. Excellent. Good. And then our range is what? What is our lowest value and what's our highest value?
Negative infinity and then positive infinity.
Exactly, right? Because there's a value that goes down here and it goes all the way up forever here, right? All right. And so you could also write all real numbers like this if you wanted, right? Or all real numbers. I don't care which one you write. All of those are correct. Okay? Cool, cool, cool. All right. Should I give y'all a second to make sure you get this all written down, or are we good? All right, we're good? Soup. All right, last ones. So, do you all have graphing calculators? Or you're on your school computers, right? You can go ahead and use the TI whatchamacallit thing. Oh, April, were you not done? Oh yeah, there's one more page. All right. If y'all don't have a graphing calculator readily available, I do want y'all to see if you can figure out how to use the TI Inspire software. That should be on your computers. Okay. So go ahead and open that up. I am opening mine right now, and then I'll share that screen. I have a lot of screens shared right now. It's a whole adventure. All right. All right, here. Share screen. I'm just gonna share all the things. Yes. Oh God, there's so many things happening right now. All right. Give me a second to make this less insane. All right. There we go. Okay, can we all see? Oh wait, we cannot all see that. That's not good. All right. How do I make y'all see this?
Your camera's off,
I know. I don't want y'all to see my face.
bro.
That is not a thing that y'all need to see. There we go. Perfect. All right. I think it's this one, right? Yeah. I haven't actually used this before. I didn't realize there was one of these things. Graphs, right? Cool. Let's do it. All right. So for this, if we did log, and then can I do a base? Oh, you found it? Okay. Does everyone find it? Does it look like this one? If it doesn't, we have problems. Yes. Okay. See, does everyone? Can y'all try to open it at least? All right. Okay. I mean, fair enough, April. It's valid. It's valid. Okay. I just need to figure out how do I use this. God damn it, y'all! I should have practiced. This is unfortunate. Okay, it's not working for y'all. Okay. Do y'all know what Desmos is? Okay. Is it not this one? Okay. Here is what I'm going to do.
It was that one.
Huh?
It was that one you had.
Okay, I don't know how to use it, so I'm going to use Desmos, which is free, and y'all can also use it. Because it's what I know how to use. It's what I've always used. Yeah, let's use Desmos. All right. So y'all know Desmos? Maybe. I hope you do. If you don't, no, it's a great.
Is it like PEMDAS?
No. What?
Oh, you said Desmos PEMDAS.
Okay, so just type in Desmos into your Chrome or whatever browser you're using, okay? Okay. If you want to use the TI calculator, you can. I just am not good with it, and so I'm not going to. All right. So from here, we need the log of x, but we need a log. How do I do bases in here? I don't remember. No. Yes, right. This is not good. Right, so if you were in Desmos, you would use this guy. So one sec. So very quick, remember you're gonna need this keyboard right here, right? And then you're gonna go to functions, all right? Miscellaneous,
Your
and then
Xbox is loud.
what? All right, and then from there you're gonna hit log A. All right, you're gonna put the 3 in the base over there, and then the x over here. Okay. All right. So we're gonna graph that, and we're also gonna graph the exponent, right? So 3 to the power x. All right. So hopefully y'all are able to figure out how to graph that. What noise, David? I'm sorry. There's so much noise. I don't even know what mic I have on right now. All right. So is this what we got? Oh, you know what? I think my computer, I've like overloaded it with stuff because it's also doing 8 other things. I'm sorry. I will try to fix it for next week, okay? I think what I'm going to do next week is I'm going to use my other computer. I'm sorry. We'll finish soon, okay? Like, this is literally, we have 2 problems to do, okay? All right. So, from here, this is our graph, right? Yes. We can all see it. All right. So, we're just going to sketch that graph. That's all you need to do. No, you're not going to have any homework this weekend. Someone is calling me.
Turn that droid off.
All right. So, when you graph this, just go ahead and sketch a graph and then label your graphs, okay? All right, so it's like out of 10, right? So sketch it as best you can. It doesn't need to be perfect. You just want to get the gist of it, okay? And remember to follow your asymptotes pretty well.
We're gonna need to find the domain.
Patience, just do that.
Yes, that's her name.
All right, so go ahead and sketch these if you're not already sketching them.
Do we need to find the range?
We don't need to find anything at the moment, okay? Literally just sketching them. So just draw them in your graph and then you're done. All right, so it should look something like, let's see if I can share my screen. What happens if I share my screen? Does it like bump mine out? What can y'all see right now? There we go. Okay. Okay, so it should look something like this, right? Did y'all leave? Are we good? I don't know. I'm just talking into the void. Y'all.
We're still here.
Okay.
Oh.
Sorry, I have like too many computers going on right now. There are literally 3. It's ridiculous. Anyway, that is what we should have graphed, right?
Computers.
Okay, so do we see how those are inverses? That's really the only point of this.
Mm-hmm.
Okay, and like the reflection line, like the line of reflection would be here, right? Does that make sense? So these are inverses.
Is that all?
That's all you had to do for that.
Someone's.
It's like a very weird order. I don't know why that wasn't like first. That would make more sense. But anyway, here we are. All right. So from here. All right. So for this one, all we have to do is talk about what mistakes you made. So what mistake did you make? So this is what kind of graph? It's a log graph, right? All right. Does this look like a log graph based on what we just did up here?
It looks like an exponential graph.
Right. So they did the wrong one. So they drew an exponential, right? Or the student, I don't know. She drew the inverse. An exponential graph. Instead of a log graph. All right. And so what she actually, what she drew right here, sorry that this is tilted. What she drew right here, we could write our equation right. This is f of x equals 4 to the x power, right? Which we can tell from up here where these are inverses, right? It's the same kind of pattern. So she drew the inverse instead of a log graph. And the log should have been down here, right? Make sense? How do we feel? Are we okay?
Who's she?
She, I don't know, the generic like person that they're citing here.
Oh, the student?
I guess. I don't know. I am the wrong person to ask because I did not write this worksheet. Okay, does that make sense? Are we okay? Do y'all want to do any of the practice problems together, or do y'all feel okay with this? Okay. I'm not sure what the yes was for. But, okay, if you want to do practice problems, is the yes that we want to do practice problems, or is the yes that y'all are good? That's my question. Okay, see, I'm confused. I'm a confused person. There's too many yeses. Okay, good deal. Oh, can we do the next class at 2? David, you can like
In the
convince
morning?
people. No, I refuse to do class at 2 in the morning. I used to do that. That was exhausting.
Yeah, why not 5?
I only teach until 3 p.m., Eric, after which I get to relax.
Yes,
Leslie,
dude.
Yes?
I think Leslie has a question.
Oh, what's up, Leslie? Wait, where'd Leslie go? Leslie, what's your question?
Wait, I have a question, but can you like go up so I could take a picture? It's because I was in the kitchen when you were
Yeah.
doing
No,
that.
you could. I'm gonna scan this as soon as we're done with the video chat and post it in the class notebook. If you like, if
Okay.
that's easier. But like, here you go if you want it. Up to you. All right.
Can you like go up? Yeah, yeah.
Is
It's
that good?
frozen.
Oh,
Yeah, it's good now.
okay. Yeah.
Okay, thank you.
I decided I'm doing 2 things. No worries. All right. Can we do the practice at a later time? Yeah, that's a good idea. All right. So I'm gonna let y'all do the practice, and then if y'all have questions, we'll do like a questions thing at some point. And I'll have the assignments up for next week, probably sometime tomorrow. I am really happy that you started using colored pens, Nicole. Your life will be so much better. David, in answer to your question, you can convince everyone else to change the poll. So next time we do class at 2, but you have to convince everyone else. April, all jobs require logic, and that's what you learn when you do math.
All right, everybody here. We're gonna have to do the class at 2. All right. Your opinions don't matter anymore, and I think that's the importance in not 2 a.m. We wouldn't mind 2 a.m., but I do 2 p.m.
I would rather not. You know?
If you guys are down to do 2 a.m., I am willing to do 2 a.m. 2 a.m. is nothing
Also
for me.
awake at 2 a.m. In fact,
I'm asleep at 2 a.m. Thank you very much.
oh, okay, like a normal person.
Yeah.
Okay. Well, the thing is, if I like I don't mind doing that too. But you have to convince the rest of the class, David. Otherwise, it doesn't work. Leslie, you're such a healthy person. You go to sleep by 9? I'm impressed. All right. Good deal. All right. So, if there are no more questions,
I got a question.
oh, what's up?
Could you do practice?
Do you want to do the practice right now?
Yeah.
I feel like you should try it by yourself. Kayla made an excellent point. You should try it by yourself. That would be a healthy thing to do. And then I can help y'all if y'all have questions. All right. Okay, bye, Gracia. All right, I am also going to leave, which means I'm going to end this recording because I just realized I didn't do that. So they're just listening to us. All right, stop recording.